The broadcast is now starting. All attendees are in listen-only mode.
Hello, thank you for joining me today. My name is Megan Foster, and today we'll be discussing addressing data silos for enhanced reporting. Again, my name is Megan Foster. I am an Agile and IT project management consultant with MTM Services. I have a background in health informatics and data warehousing solutions. So we'll go ahead and jump in. All right, so today, some of the learning objectives that we'll discuss are data silos in the case for data integration, master data integration, approaches to data integration, and I apologize, the point here should say master data management, and then approaches to data integration, opportunities to improve data flows and to improve access to cross-functional data. So first, what are data silos? And I'm sure most people on the call are very familiar with the idea of having data in multiple places within your organization and not being able to connect them in meaningful ways in order to have a more comprehensive view of what's happening at an operational or clinical outcome level across the spectrum. So data silos occur when data are stored in isolated systems that don't communicate with one another. And these are quite common, as I mentioned. We have laboratory information systems, pharmacy information systems, radiation or radiology information systems, clinical information systems, financial information systems. And quite often it takes a lot of legwork and processing to get these systems to speak to each other. And so the case for data integration in this regard is that data integration offers a backbone in a fluid and ever-changing and ever-growing environment. So as the environment changes, the data sources change, having a data integration strategy will help you improve productivity, improve data quality. You're able to, as I mentioned, gain a holistic business view, improve your data flows, and improve access to cross-functional data. So of course, when we are looking at improving productivity, this means that we are looking to automate data flows and reuse those frameworks and templates to accommodate new data types and use cases as they appear and change within our clinical work systems. Data quality, just as it sounds, is the goal to standardize and ensure quality is ensured before it's made available to the end users for decision making. When we talk about gaining a holistic business view, this means that we want to be opportunistic when we're looking to combine these data sets. And so getting the right data sets integrated so that, again, we have that comprehensive view and full picture, because quite often with these disparate data sets, we're only looking at a piece of the continuum for patient care or for operations, and having to make a decision off of just one component versus the full picture, of course, limits our ability to be effective in our decision making. So that timely access to valuable business insights can give a competitive edge to stay ahead of the curve and stay ahead of any signals within the workflow and clinical environments that may need more investigation or may need more attention. Then, of course, with better data flows, we have the opportunity to have a better governance over our data. we're able to secure it and make sure that there's an ease of flow between systems. And then it gives us more visibility from end to end to make sure that, again, we are complying to data governance goals and maintaining compliance according to our organizational and regulatory policies. And then, of course, with cross-functional data, we are able to kind of modernize the journey. Again, we're looking at bringing in data and getting the right data together so that we are able to have a more complete vision or a complete outlook on the organization. And so with all of these benefits, we're able to improve our reporting, improve our decision making, and ultimately help our consumers with better experiences when they come into care. So data integration is mostly used for consolidating data for analytical purposes. When people are looking to take on this step to integrate their data, there usually is a need for normalizing the data, transforming it so that it is able to be used for different analytics and decision making. And so this chart on the right is taken from a survey where respondents were asked, kind of on a spectrum from critical to not important, how important are these different use cases for data integration? And so we see dashboards and reporting are noted as the most critical by almost 50% of the respondents. Ad hoc querying is the next highest that is ranked critical. And then we also have replatforming, replication of existing data warehouse, data science, and augmented analytics. So outside of healthcare, there was a study done in the same regard where respondents were asked, what technologies and initiatives initiatives are strategic to business intelligence. And 80% of those operations leader from service delivery, manufacturing, supply chain, they say that data integration is critical to their success. What we see surrounding that in this image is reporting is noted as the most critical. Dashboards are next. Right below data integration, we see data preparation and blending, data warehousing, end user self-service. I think that arguably we could say that the data integration and master data management solutions underlie the capabilities to deliver reports and dashboards and end user self-service. And so while this survey did not include healthcare, it is important, and I think most of us realize that healthcare tends to adopt a lot of the things that work in other industries, especially other high reliability industries such as manufacturing and aerospace. So in this regard, we also want to look at data as a product. So the last slide mentioned self-service tools. Self-service tools, for example, alleviate some of the workload for our IT staff and data analysts or data engineers, and that we're able to deliver the data, and then we're training our end users to be able to manipulate it and give us feedback and tell us what other data they need to be able to make their own decisions, and really just giving them the space and knowledge to be more self-sufficient. And in essence, that is data as a product. We want to facilitate an end goal through the use of data. This is also important because 30 to 40% of the of reports that businesses generate daily add little to no value. And I'm sure most of us on the call have reports that are generated, maybe it's weekly, maybe it's monthly, and we probably haven't looked at it in a month's time or so. Just because it doesn't provide any value, or it doesn't give us the insights, or maybe it's missing data that would be critical for it to be more informative. Some of these reports are duplicative, and as I mentioned, they go unused, with the result that considerable resources are wasted. So even though the reports may not be used, there is a lot of effort and time that goes into it on the back end to make these reports, available to people. But if they're not being used, then of course that is generating waste within our system. And so this chart here gives us an example. If we are looking at data as a product, it gives us an example compared to digital products like a computer app versus a physical product like a car. So the product features for a data product, the customization of base product for different users. So data products can be wired to support different systems that consume data, such as advanced analytics. So maybe you're linking it to your Tableau or Power BI, or reporting systems. Maybe it's SSRS packages or you're delivering even Excel sheets. Those could be considered a product. Delivery of regular product enhancements. So this means integrating new data and then providing support for additional consumption archetypes. And then in terms of efficiency, that reuse of existing processes, machinery, and components, we're able to kind of take these data products and reuse them as blueprints and modularize them again, so that we're able to kind of take those components and reuse them as new data sources become available. So this brings us to the idea of master data management. And what this means is that we are looking to maintain a single version of truth across the entire organization. And this is obviously going to be high priority for most organizations looking to create data integration solutions or integrated data solutions. Because we also want to understand how that impacts compliance and regulatory obligations. So as we're looking at master data management solutions, we really want to focus our attention on improving data quality and processes, establishing guidelines for data governance, and then also ensuring data can be easily managed and accessed across the business. So most of these factors can be achieved by using different implementation styles, which we'll talk about next. But it's important to keep in mind that because most organizations' operations are going to be very specific to that organization, the master data management approach or even type of deployment will depend on the core business, the organizational structure, and most importantly, the goals of the master data management strategy. So some of the benefits of having this single source of truth across the entire organization is that first, it improves efficiencies. So with all of the organization's most critical data just in one shared location, you can eliminate information silos and also increase collaborations across departments and even within the team. This also allows us to build confidence in the data. So again, by reducing the data silos, the mission critical data is now centrally governed and maintained. So we understand the business rules. We're being able to consistently apply them across all of our data and really have a standard for what it looks like to be confident in our data. And I think most people would agree that building that confidence in the data is one of the initial barriers or speed bumps that most teams have to overcome in getting their teams to take a more data-driven approach to decision making. Also, it saves resources. So with an automated or streamlined data process, you're able to save time on manual activities that could drain your time and resources of your data teams or IT teams. And then ultimately, we want to provide more value. So again, eliminating those data silos, now you can take advantage of the insights that are derived from delivering the data, being able to get feedback and incorporate that feedback and continuously deliver value, again, from that single source of truth. So some of the principles around the master data management strategy is, one, we want to have a clear origin of data. So we want to know what the initial source of data is and how we define that. Most often that's going to be where the data entry occurs. This is important because when we're looking to develop a single source of truth within the organization, it also raises the question of, well, if there are errors in the data, at what point or phase of the data workflow do we make those changes? I can say that most often we're going to go back to that original source of data and want to make the corrections there. There are some caveats, again, just depending on the size of the organization, the capability of the people who are entering in the data to actually go back and make those changes if the changes are actually needed. Again, there are going to be different use cases for some of these principles, and it's really going to depend on the organization itself. We also want to strive for clarity. So we don't want to convolute the process. We want to keep it simple and be able to translate these processes back to our business owners and other stakeholders in a concise and comprehensive way, because that allows us to get their feedback and incorporate some of those business principles and strategies and business rules into our data flows. So that clarity, not just from the IT side, but also in our communication with our business stakeholders, allows for us to achieve the benefits of this master data management strategy. We also want to strive for completeness. So wherever we have data that is missing or is inconsistent, maybe we want to make sure that we're identifying those gaps and really build into our strategy how we overcome those things. And a lot of times that will kind of go back to the original data creators or reporters, and it may require training, or it may require updates to the user interface to make sure that if a field is important or a data point is important for analysis, maybe it's now required. So making sure that we're accounting for those things in our strategy. And then ultimately, we want to make sure we're performing regular maintenance. And again, having everything in one place, being able to apply the same data governance strategies or principles across the entire spectrum of the data or database allows us to be more consistent in performing maintenance and making sure our data quality is up to standard. So there are a few strategies, and again, I'm not going to take too much of a deep dive here. There's a lot of information about these strategies online, but I just want to kind of hit some of the high points in terms of what it looks like to employ some of these styles. So the first is the registry style. And so this style is used to identify duplicates, and you do that by running and cleansing and using matching algorithms on the data from your various data sources or data systems. And then it assigns a unique global identifier to the records that match, and that allows for that single source of truth. So you're applying this global identifier once you've matched the records from these different systems in order to create that single source of truth. And so this is a low cost approach, and the benefit here is that it is minimally intrusive compared to these other styles, and sometimes it allows for just easier integration that doesn't require a lot more than just, again, matching the data from the systems and creating that universal ID. Then we have the consolidation style. So the master data is consolidated from multiple sources in the hub. And again, we want to create that single source or version of truth. And then with this style, the single source of truth is stored in a centralized hub or database, and that is used for reporting and reference. The case here with the consolidation style is that any updates that are made to the master data management or centralized database are then applied back to the original source. So one thing to remember here is, how do we want to handle corrections to the source data? Because that will, in essence, dictate which style will work best for our use cases. Then we have the coexistence style. So this works similarly to the consolidation style, but the difference is that the master data or single source of truth is stored in a central system and updated in the source system. And so we're not updating it in the master system, we're instead updating it in the source system and then pushing that data back to the master data management solution. And then the last one here is the centralized style. And so this allows you to store and maintain the master data attributes, again, using linking, cleansing, matching, or other matching algorithms to create that single source of data. And then the enhanced data that you now have can be pushed back to its respective source system for consumption. And so these are just some high-level techniques used to, again, build a strategy around what does it look like to create that single source of truth. And again, with regard to if there are errors in the system, where are we going to go to make those corrections? All right. So that brings us to approaches to data integration. So of course, data integration does play a key role in the healthcare industry. With integrated solutions, we can look to patient records to provide a unified view of complete information regarding a patient, but also help doctors in diagnosing their medical conditions. So effective data acquisition and integration can also improve accuracy for our providers through, again, a more comprehensive view of the patient journey. And so we have 5 different approaches here, and I'll go through these individually and just kind of discuss some of the pros and cons associated with them. So manual data integration, this is a process of integrating all the different data sources without any animation. And I'm sure a lot of teams have adopted this. This is where we're going in and doing a lot of the data cleaning, a lot of the reformatting manually. So there are some pros to this in that you do have absolute control over the data integration and management. And then there are no additional costs associated with the manual data integration if you already have a team in place to whose role it is to do these manual processes. The downside or the cons is that other members of the business may find it hard to access the data or analyze it. It is very hard to scale manual processes, of course. Also, errors are likely, one, just because we're human, but then when you add complex data connections or big data queries where we're exporting data from different systems to apply these manual processes, errors are more likely to occur. And then, of course, data engineers must individually and manually code connectors to different data sources every time a system needs to be accessed. So again, it's not the most efficient, but it does have some benefit in that we're still able to integrate the data. So overall, the pros here is that it's reduced cost and more freedom, but on the opposite side, there's greater room for error and it can be difficult to scale. Then we have data integration with middleware. So middleware is a software that is used to connect applications and transfer data to databases. And so as you can imagine, it can be very handy when we're looking to integrate legacy systems with newer ones, or even integrate newer systems with each other. And so as the name suggests, middleware sits between applications to transfer the data, and is usually automated and can often perform the transformations that make the data compatible with new systems. And so the pros here are that your network systems will communicate better with effective middleware, and enterprise data automatically transforms and transfers in a consistent manner. And so comparing this to the manual processes, we're kind of eliminating some errors here, because once we have that middleware set up and configured to transform and transfer the data, it will be able to do that consistently every time. We're not at risk for human error like we are with the manual data processes. The downside here is that enterprises require a skilled developer to install and maintain hardware or middleware, and that can increase operational costs. Also, not all systems are going to be compatible with middleware. So again, the pros here, you have better data streams and easier access between systems, but the downside here is that you may have less access and limited functionality depending on the middleware solution. Another approach is referred to as uniform data access integration. And so what this one does is take data from multiple disparate sources and aims to present it uniformly. So another useful feature of this method is that it allows the data to stay in its original location while doing this. This technique is good for organizations that need access to multiple disparate systems without the cost of creating a copy of the data. So some of the pros here is that you have a simple and unified view of the data. This allows multiple systems or apps to connect to one central source, and there's no high storage requirement because, again, we're linking back to the original data source. Now, I would argue, especially for teams that are looking to employ an integrated data solution, before you jump right into a database and automated ETL, extract, transform, load processes. This approach may be a good in between or midpoint to give the data to the end users, allow them to start working with it, understand where the inconsistencies in the data are, what data they need connected to it in order to make more informed decisions. And then that way, by the time you're ready to move on to a more advanced approach to integration, you have a lot of the business requirements sorted out. And maybe even the data has been cleaned up and sorted out as well, so that now the ETL process and building flows around it is going to be a lot more simple. The cons of this approach is that accessing data from within source systems can cause frequent data access requests, and that can put a strain on the data host systems, limiting the functionality or lead to latency problems. Also, having multiple data access points can compromise data integrity and data quality. So again, the pros here is that there are low storage requirements, it's easier to access, and you have a simplified view of the data. But on the other hand, it can strain systems and pose data integrity challenges. So this method is called the Common Storage Data Integration approach. And with this approach, it is similar to the Uniform Access Integration approach, but the difference here is that it does create a copy of the data in a data warehouse. Here, the data is probably more complex and abundant, and the common storage option just allows for more control of the data. So some of the pros here is that this means that there's less strain on the data host systems because now you're not connecting to it directly. You have a data warehouse that is designed for those access requests and data pools. And it's all stored in one destination. It also provides uniform data appearance to streamline analytics so that we're comparing apples to apples across all departments. Everyone has the same view. We're also able to maintain higher data integrity. Just think of some of the constraints and opportunities that relational databases offer, and that we're able to make sure that more quickly identify any duplicated errors, any missing data, any inconsistencies. We're able to check values and make sure that the values that are within a field are as expected. And then with all of these things mentioned above, we now have more opportunity for effective analytics. The cons here is that the cost for data storage could increase as data volume bumps up. And we know that data in the healthcare industry multiplies exponentially. And then unless you use a third-party data warehouse, there could be maintenance costs. So some of the pros here are kind of that reduced burden on the host system. You have enhanced capabilities for data analytics and cleaner data. So that also will help improve reporting. But on the other side, there may be high storage costs and high maintenance costs. And so this last one is application-based data integration tools. So with this method, the software does all of the work. They locate, they retrieve, and integrate the data from the different sources and systems. And this strategy is mostly used in organizations that have a hybrid cloud environments. We don't go into cloud today, but this approach would be for those more complex systems that are looking to integrate more cloud technology. The pros here is that you now have this seamless data transfer and exchange of information between the different systems and destinations. It's also easier on resources thanks to automation. So again, compared to that manual data process, we've now fully eliminated that manual data handling. And now your resources can focus on looking at the output and maintaining data governance and data quality and responding to those issues instead of having to build the actual automation solution. It's scalable as the amount of data you consume increases, and is simple to use and doesn't always require a technical expert. The cons here are if you are on-premise software or using on-premise software, you may need an expensive technical expert on site to manage and deploy the solution. So again, some of the pros here is that it's going to be easier to exchange information, and there's going to be a simplified process for your data teams and IT teams. But some of the cons here is that it may require, as I mentioned, a more expensive technical expert to manage the solution. So when to use it? Just to summarize these approaches, for manual data integration, this is going to be best for merging data for basic analysis between a small amount of data sources. Middleware data integration approach is best for automating and translating communications between legacy and modernized systems. Application-based, we're looking at automating and translating communications between systems for more complex data analysis. Uniform access integration, we'll use this when we're looking to automate and translate communication between systems and present the data uniformly to allow for more complex data analysis. And finally, common storage integration. This is where we want to present the data uniformly, create and store a copy of it, and perform more sophisticated data analysis tasks. And so I know that a lot of these points have been pretty technical, and so I thought it would be important to include that there are low-code platforms out there and available, and the market is increasingly growing to help bridge the gap between just technical skill availability within organizations. In 2021, the low-code platform market was valued at $7.61 billion, and it's projected to reach $36.43 billion by 2027. By 2024, it's estimated that 80% of non-IT professionals will develop IT products and services, with over 65% using low-code or no-code tools. And so for the non-technical people on the call and who are listening in, I hope that this gives you some confidence that there are some solutions out there that may not require you to be a full-blown IT professional, but with business acumen and some level of understanding kind of what your goal is, what that master data management strategy is, you would be able to leverage those to achieve some of these platforms to achieve your data management goals. And so here we have just some reasons for using low-code platforms. Almost 70% say it accelerates digital innovation and transformation. It helps reduce IT backlog and increase responsiveness. You're able to kind of escape some of that legacy debt, reduce dependencies on hard to hire technical skills, protect against technical churn, and enable citizen developers to improve internal processes. And so what is meant by a citizen developer? That is an employee who creates applications capabilities for consumption by themselves or others, for consumption for themselves or for others, using tools that are not actively forbidden by IT or business units. This is not a title or targeted role, it's more of a persona, and they report to a business unit or function other than IT. But the idea here, and we're seeing a lot more conversation around what it looks like to have citizen developers, again, to help fill the gap where technical skills may not be available. So with low-code platforms, what this means is that we're able to deliver value faster, again, for teams that may not have the technical skills readily available, or are even looking to just modernize or advance their data handling capabilities. Low code could mean that you don't have to use code, so it's code optional. But if you do have developers within the team, then they're able to incorporate some handwritten code or modify the code and customize it for your solution. And then there are no code environments that are fully visual environments and graphical platforms that require no coding at all. And so here on the right, it says more employees working on innovating products accelerates the whole company's advancement towards digitization. So even as I mentioned that this low-code platforms are a great solution for cases where technical skills may not be available or maybe already, stretched thin. The other idea here is that these platforms give other team members the opportunity to also collaborate on solutions, given that the technical competencies that are needed are much lower. And that way, we're able to all kind of sit down and speak the same language about what we're looking to achieve. So some best practices in general for ultimately data or linking data. First, we want to keep in mind that any rules applied for missing values should be managed consistently across the data set. So for example, numeric values, you may want to use -999 or require that the missing data value be updated prior to including them in the analysis. You also want to look at creating processes to identify and manage duplicate records, inconsistent or erroneous data. So building in your strategy kind of proactively to be able to identify and manage these common errors, which include duplicate records and inconsistent or erroneous data. And then finally, normalizing data and converting it to categorical data when you can. That way you're able to improve aggregation capabilities and open yourself up to more opportunities to link the data to other data sources. And then overall, just best practices for data integration, just to summarize here. So first, of course, we need to identify the data sources. So this means just knowing where all the critical data resides. While a lot of critical data resides in our different clinical information systems, there may be critical data that may reside within a department. Maybe there's manual tracking happening that could be automated to improve decision making and then shared with other departments, again, to provide a more comprehensive overview. So we want to keep that in mind, that it may not just be our clinical information systems, it may be data holders within our departments and within our clinical work systems that are also critical to providing that bigger picture. We also want to prioritize data privacy and security. So making sure our security protocols are in place. We want to make sure we're having regular security audits to ensure compliance with the relevant data privacy laws and regulations. And then finally, implement standards such as FHIR and HL7, because these standards provide a common language for data exchange and allow healthcare organizations to share patient data more easily. All right, so that concludes the presentation. Again, thank you guys for joining today. I hope you were able to have some takeaways to take back to your teams. And here's my contact information on the screen. Feel free to reach out with any questions that you have for me, but we also have some time now for any questions you have. Feel free to add them directly to the chat, and my colleague Jody will read them out to me for me to respond to. Okay. If we do not have any questions, we may conclude here. Jody, are you seeing any questions come in?
No, Megan, I don't see anything coming in, so we can conclude the webinar, and probably in a couple days we'll have it uploaded to our website and you can go in and review the slides.
Awesome, thank you. Thank you all for joining us, and have a great day.